Hello, and welcome to our final backend project. We're going to be building an API, putting together everything that we've learned into a large full-stack website. As part of the Artemis project to bring humans back to the moon, NASA has asked us to explore the next step. The possibility of bringing humans beyond just our own solar system to the Kepler exoplanets. We'll be building a NASA mission control dashboard to schedule missions targeting those Kepler exoplanets. This is the fun part, so let's just jump straight in. Anytime we build a full stack web application with many different front-end and back-end components, it often pays to think about the structure of our project, to do just a little bit of work up front ahead of time, so we're not moving code around all the time as we figure things out. That's not to say that we're not going to make improvements and changes as we think about them, but we do want to have a general idea of how our code will be structured. This is the kind of work that the architect or senior developer on the project often does when the project is just beginning, so that the project gets off on the right foot. The fact that our NASA application is full stack means that we're going to have a server component for the API. So let's make a server folder where that'll live, and we're going to have a client component for the front end. We'll be working with both this API and integrating it with the front end because as Node developers, even if our primary job is building APIs on the back end, we need to understand exactly how those APIs will be used so we can build the right thing. Plus, it's more fun if you can do both the front end and the back end and really see those APIs of ours in action in a full stack web application. Okay, so where do we go from here? One of the things that we do as project architects is to build these architectural diagrams. These help us visualize the different parts of our project and how they interact. One tool that I like to use for this is Lucidchart. Right now, it has a pretty good free tier, but if you'd like, there's other tools you can use, like Microsoft's Visio, there's Glyphy, there's a really old school open source one called Dia, and even things like Photoshop or Sketch. Choose what you're comfortable with. I'm going to call this the NASA Mission Control Architectural Diagram. When it comes to these diagrams, we can choose to be as specific or as general as we'd like. And there's often value in having both very specific diagrams that break down important flows and actions, and also high-level diagrams, which help us and our team to understand how everything fits together. So for now, we'll keep it simple and say that we have a web application, which is our front end. So let's make this nice and give it this blue background. There we go. And this is going to be talking to our Node API. So I'm going to copy that and say the other main piece of our project is the Node API, with the web application sending requests to the Node API. requests which are going to be over HTTP. And this is all part of our NASA Mission Control project, which contains both our web application and our Node API. So I'm going to move that to the back so we can see what it contains. And I'm going to say that it uses this dotted line as this rough grouping of these two different components. All right, that's a good start. We can visualize the two main components of our application and how they interact with each other using HTTP requests. Now that we have a high-level view, which we can expand on, let's get back to our project. Now, we'll get to the front end, but this is a Node course, and backends are where Node really shines. So let's start with what the folder structure should be for our server. We're going to be using our framework, Express, and the pattern most Express servers use is MVC. The MVC pattern can be visualized in a few different ways, but the main idea is that we have models, views, and controllers, and that the user uses the controller in some way, which then updates the model, and the user gets back this updated view in response. So we're going to use this pattern in our server. We're going to be working with data, so we definitely need a models folder, and our API is definitely going to have some routes. So let's create a place for those. Now, what about our controllers? We could create a new folder for those. So say controllers, and have that in our server. But for larger applications, it tends to be good to keep related code together and only separate code that deals with different functionality. We'll see exactly what that looks like when we start writing our server. But for our structure, it means that our controllers are going to live alongside our routes, because the controller defines how we respond to that specific route. So the code that defines our API endpoints and the code for our controllers will be side by side under this routes folder. So let's get rid of that controllers. And what about our views? Well, we're a client-server application. Our client is going to be a dedicated front-end project, and we're going to be sending data which it will be in full control of displaying however it chooses. And so this is actually a good start. We don't need to overcomplicate our folder structure. Now we do know that we're going to have a server.js where we'll start up all that goodness that our server does and make use of our routes and models. Now, before we start coding, to get us in the right mindset, it's worth realizing one thing. In these large-scale applications, where we have multiple different pieces, like a front-end and a back-end, it's common that we create multiple node packages for those different parts of our application that all live inside of our main project folder. What this means for us is that our front end, our client, will have its own package.json. Our server will have its own package.json. And believe it or not, we'll have a package.json at the root of our project folder, which wraps the two packages for our server and client, so that we can run npm commands from our project folder that perform actions, like starting the server, on each of our inner packages in our server and our client. Now, our package.json should always be created by an npm init command and be managed by npm, as opposed to us, for example, writing out all of our packages by hand. Instead, we want to run the npm install command. So let's get rid of all of these. We'll be doing things the right way with npm very soon. But at least now we have an understanding of what our overall project architecture will be. All right, that's enough for now. There's only so much that we can understand by just talking about it. So let's jump into some code. I'll see you in the next one. Let's go. Welcome back. We're in quite the position of responsibility here. The engineers at NASA have told us at Zero to Mastery that the front-end code is ready to be integrated with the backend. They've handed us this front-end application using the popular React framework. If you haven't used React, don't worry. We're going to cover the parts that are relevant to us. But everything we really dive into when it comes to the front end will apply regardless of which framework we're using. Or even if you're just using plain HTML and JavaScript. So there's no reason to be intimidated. But what we have here is not unusual. This is a common situation in web development. The front end is often made ahead of the back end. So we're getting some good real-life experience here. The truth is, the front end usually needs to be modified after implementation on the back end is underway. Because it's very difficult to predict the exact constraints or even implementation choices that will be made on the back end when you're writing this code ahead of time. We still need to actually implement the backend logic and data that makes all of this work. Let's see what those NASA engineers have sent us in this zip file. We got a folder, and inside, we have our front-end project, which we'll copy into this client folder of ours. We'll make sure to copy all our data, and if we go to the README, our NASA engineers have set up this React application using Create React App, which is a tool to quickly set up React applications, which I highly recommend you use when starting out writing React. Create React App lets us focus on code rather than the complicated build systems that are common in modern front-end frameworks like React and Angular. It simplifies our life, for example, by bundling our files together so they can be sent directly to any browser without us developers having to take any extra steps. And it does a lot more than that. We can see that our front end is an npm package. We have a package.json with React as a dependency, and a few scripts using React-scripts, which is the tool that Create React App uses to make our lives easier. We're also using ROS, which is this beautiful science fiction UI framework that we'll be using for all of our components. Now, as an npm package, we'll need to npm install our front-end code before we do anything else. But because our package.json is inside the client folder, we need to change directory first before we can do that. Before npm will be able to find that package.json. Now, from the client directory, we can npm install. Our dependencies are installing. There's quite a few of them, so it might take a little while. And here we go. We're ready to run our scripts and start our NASA front-end application. npm start. And our browser is starting to load our page at localhost on port 3000, which is the default for Create React App. Check it out. Those NASA front-end engineers prepared this beautiful dashboard for our mission control front end. We're going to have a lot of fun building this out. So let's explore our front end in the next video. We'll break it down to understand how it's implemented and learn what still remains to be done on the back end. I'll see you there. Bye for now. Welcome back. What have we got here? Our NASA front end is being served on port 3000. Let's see what functionality our mission control dashboard needs to support in order to launch NASA missions towards the Kepler exoplanets. On our main page here, you can see our criteria for habitable planets. They're only confirmed planets that match the criteria of having a planetary radius less than 1.6 times that of Earth, and this stellar flux value, which measures the amount of starlight or sunlight that those planets get compared to Earth. So it needs to be at least 36% the amount of light that Earth gets, and less than 111%. Because then things would get just way too hot. We have this launch date, which we can set, and it needs to be a date in the future compared to today's date. Something we can set with this calendar picker. We set a mission name. That's just some text, like Kepler Exploration A. We have a rocket type that defaults to our Explorer Interstellar 1. This is a rocket that is specific to our Kepler exoplanets project here. This doesn't exist currently. And we can set our destination exoplanet. This is going to be the list of planets coming in from our API that will populate this dropdown, allowing us to choose the habitable planet that we're targeting for this launch. And when we're ready, we can select Launch Mission to add that launch to this upcoming tab, which will eventually include both SpaceX missions and our interstellar zero-to-mastery rockets. For each upcoming launch, we'll keep track of the flight number, the scheduled date for that launch, the mission name, the rocket being used, and of course the destination, that exoplanet which we're hoping to explore. We'll also have the ability to abort the mission by clicking on this X symbol somewhere in this list. And under History, we'll be able to see all of the launches that have either succeeded or failed in some way. Maybe they've been aborted from the upcoming list by clicking that X. And in this history list, we include a similar set of data about our launches, but rather than displaying the destination exoplanet, we show this list of customers that are paying for or using this mission for some goal. So we have future missions under upcoming and previous missions under history. All right, very cool. But right now, we can see that even though our UI is interactive, if we try to schedule a new mission, say fancy Kepler Explorer, we don't have any of these possible exoplanets in our dropdown, and we can launch our mission, but nothing happens. We just get this error sound indicating that we weren't able to schedule our launch. We need an API for our dashboard to actually do something. It's time we dive into our NASA engineers' code to understand what we're already doing and what we'll need to implement on the back end. I'll see you in the next one. Welcome back. Do you mind if I ask you a question? Are you already familiar with the React front-end framework? You're not? Oh, that's completely fine. For the rest of this course, we don't assume you know any React. However, as a backend developer, it's good to have a general idea of how a front-end project might be structured. As backend developers, it helps us to know how the front-end will interact with our backend API. For that reason, we're about to have a whirlwind introduction to a front-end application that uses React. There's going to be a lot of new terms and concepts that we mention, but don't worry. We're only mentioning them so you can get a taste for how React works. The goal of the next video is for you to have a general idea of the structure of our front-end project. The front-end project that will live in this client folder. We want to have an idea of what's in this client folder, so it's not just some code that we copied from somewhere else. After the next video, most likely you won't be an expert on React, but you will have a general idea of the kinds of things involved in a React application. And you'll have your first glimpse of where we'll need to add code when we integrate with our backend API. Doesn't sound too bad? All right, grab a cup of coffee, make yourself comfortable, and let's absorb some front-end knowledge. Let's go. Welcome back. Here's the situation. We have a front end that's already nearly complete, and we're being asked to make a back-end API, which will let this mission control dashboard schedule missions and view historical and upcoming data as well. Our first task will be to dive in and understand how our API will be used by this client. And from there, will work together with the front end to prepare our project for launch. Let's dive in. In our NASA project, our client we've seen is a React application. Now, this isn't a React course, so we're not going to cover React from the very beginning. But let's go over what our front end is doing conceptually and see how we can integrate the endpoints that we'll be building into this code to hook up all the functionality that our dashboard allows our users to perform. I promise this video is as deep as we'll get into React in this entire course. Nothing too crazy, but also it might be an interesting overview if you've never used React before, or even if you have. Whichever group you're part of, I'm sure you're going to learn something. We're using ROS for our sci-fi components and React, as we've just discussed. We have React scripts from Create React App, which helps us build and start our React project without having to worry about any of those complicated front-end build systems. The other two dependencies we have here are React Router DOM, which allows our front end to have routes of its own. For example, for the /upcoming page, which lists upcoming launches, versus the /launch page for creating a new launch. We'll see that in just a second. And React DOM allows our React code to make use of the document object model, because our application is a web application. And the DOM is the object the browser uses to store the current page that you're viewing. There's other variants of React, like React Native, which allow us to build mobile applications, and that would use a different package to render your React application and all of its components. All right, so in our source folder, we have some files, and in public, we have some assets, some background images, and sounds as well. For our user interface, we have a favicon and this index.html, which will contain our React application. So the HTML here is all standard. It includes things like the description of the page, the favicon, and if we scroll down, we have our title, we have some style sheets, and then we have this root element, which is where our React application will get loaded. So all of these files in the public folder are those that are going to be served to the browser directly, without any fancy processing by the React framework. And the way this root element gets populated is in this index.js, where we use that React DOM package to render this app React component on the HTML element with the root ID. That's right, the one we just saw. And this app component here uses a React syntax called JSX, which kind of looks like HTML. So React code knows how to render these JSX components based on, in the app case, this app.js that we have here. And this is the main entry point of our application, where we use this ROS framework to set up our user interface theme, the sounds that we'll be using, and the ROS framework itself, which provides us all these nice animations for when we're working hard and navigating through that NASA launch system. We can think of all of these components that we have here as custom HTML elements that React knows how to render. We can use them for visual components, but also for functionality like routing. This router component comes from our React Router DOM dependency to allow us to navigate to different pages in our browser. And the component that handles our router is this app layout page, which comes from our import over here. And our theme and sounds come from this settings module in settings.js, where we have the images and sound data telling ROS where to find our sounds files, and also our theme, which has things like colors and font information for our application. Now, what about that app layout component? Now we're getting to what's important to us as backend developers. In our pages folder, we have all of the different pages of our front-end application. So we have this root app layout component, and then we have a history page, a launch page, and an upcoming page. If we look in our root app layout and scroll down, we have some custom styles for this page, but our component definition starts here, where we set up some animations for when we navigate from one page to another. We have our sounds. These functions will play the corresponding sound. And going a little bit further, we have all of the different React components that make up our app layout and allow us to show those individual pages. This should seem familiar. We have a header, which allows us to navigate from page to page and has our fancy logo. And we have a frame, this box that contains the route that we're currently browsing. So it could be the launch route over here. And we also have this launch route being rendered when we navigate to just the route for when we first load our page without any of our specific route paths. So that handles the launch. And then we also have the upcoming page and our history page. That's the overall structure of this app layout component. There's a lot going on here, so let's break it down. At the top here, we can see a header and this centered component. These are components that we've defined in our components folder here that just handle with working with centered content. And we have one for clickable objects on our page where we play this click sound when that click happens on click. And we have our footer with just some text in a paragraph that's also centered, and a header, which contains, if we scroll down past these styles, our logos, and then a series of these clickable links, which allow us to navigate to each of our pages. So /launch over here, upcoming, and so on. One of the main ideas behind React is building up these larger components using the tiniest little components, like, for example, this base HTML italic tag, and layering them on top of each other to build more complex functionality. So our components folder here contains some of these components that we've built up that we might want to reuse in our different pages. Now, the other most important piece here is the hooks. If we go to our app layout.js and we scroll just above our return statement where we return all of these components, we'll see a couple of these use functions like useLaunches and usePlanets. These are hooks, which are React's way of responding to events that occur in your application and managing the resulting state of your application. With hooks, you take the state that would live in your React components, these things like the header and the footer, or any buttons or forms that your application is composed of, and you move this state into these hooks instead, which simplify how you pass this state, like the list of planets, around between your different components, which we can see, for example, the list of planets being passed into our launch page because they're required for that dropdown. So you capture this state in the hooks, and you also save React from re-rendering your application needlessly, because React can keep track of exactly what state has changed versus what state hasn't changed, and only render the things that have changed. Let's look at this planets example. We can see planets is set to this usePlanets function that comes from our usePlanets.js. And all this is doing is returning this planets variable, which we set up here using this destructuring syntax. So our useState hook, or this useState function coming from React, returns two things. It returns this planets variable, which starts as being an empty array. This is the default value, and is then populated by making this HTTP request to get the planets from our API. And once we've fetched our planets, we can call this savePlanets function, which React has made available for us, to set the planets variable to the response of our HTTP request. And now, because we've used this function, this hook, React knows to keep track of this state in the most efficient possible way. And this useEffect hook, again coming from React, is a function that will always call this getPlanets function when the application first loads, because our list of planets is required right away. Just a really quick overview here. But that's pretty much the extent of React that you need to know for now. The same thing applies to our launches. If we scroll down, it might seem a lot more complicated, but it's the same patterns that we saw with the planets. We're managing the state of our launches array, as well as this additional variable for whether the launch is currently pending or not, which represents when the server is still processing our request. The only new hook that we have is this useCallback, which is the React way of saving our application from needlessly recomputing whatever's in this callback function that we pass into it. In this case, from getting those launches from our HTTP endpoint and saving them to our launches array. We still have this useEffect that will always call the getLaunches function when the application first loads. And then we have a few functions for submitting the launch and aborting the launch when the user presses that X symbol. And finally, we return these functions and the data they manage from our useLaunches hook so that we can make use of them in our app layout. We take these variables and these functions and pass them into whichever components they're being used in. So we can see the launch page makes use of the planet's data and the submit launch function, as well as whether the launch is currently pending or not, probably for some loading animation or some loading state. To wrap up with our hooks, all of these hooks are really just making sure that our application state is saved and any calculations or API requests needed for that state are only performed when the user performs some action that will cause an update. For example, our launches data won't be reloaded every time we switch pages because nothing has changed. Hooks are great for making our React applications more efficient and minimizing the amount of requests that our API needs to handle, which speeds everything up. Everybody wins. All right, so how do we make these requests from our front end? Well, these HTTP functions are being imported from this requests.js file right over here. But that's where we come in, because these functions haven't been implemented yet. We need an API which defines what these requests will look like. We just know that we're going to have at least 4 basic requests to get the list of planets and make it available as a JavaScript object, to get the list of launches, submit a new launch for our mission to one of the Kepler exoplanets, and to abort or delete a launch with a given ID. We have some work cut out for us. Let's get to it and start working on that mission control API. I'll see you in the next video. Welcome back. In this video, we're going to set up our Node server so we can build a production-ready API. We're going to be using the Express framework and all of the tools and knowledge that has already been built around Express. So first thing, in our terminal, we're going to change directory into our server folder, because remember, now we have both a client and a server where the client is its own NPM package. So we're going to change directory, cd, into server, and set up our NPM package, npm init -y, which will now allow us to npm install Express as a dependency. To make our development life a little bit easier, we'll also set up NodeMon, so we don't have to restart our server manually every time we change any of our source code files. So I'll npm install, and this time NodeMon will be a development dependency. It's not used by our code, but instead as a tool to make our development life easier. So that's --save-dev, NodeMon. All right, so what do we have now? Our package JSON is called server. So let's rename that to NASA-project-API, which is the NASA Mission Control API. And we can add some scripts. For example, it's common to have a watch script, which uses NodeMon and monitors for any changes during development, or watches for changes. All right, but the client that front end that our NASA engineers sent us has all of the source code inside this src folder, which is nice because it separates our configuration, for example, our package.json, from our JavaScript code. So we're going to follow the same pattern in our server, so we're consistent. So let's create a src folder inside of our server, and we'll move all of our JavaScript into this folder. So server.js, as well as our models and our routes. Now, everywhere we point to server.js in our package.json, we'll need to make sure to point to src/server. From here, we'll be setting up Express, like we did before, and I could copy and paste the Express boilerplate code, but we learn best by repetition. It helps to consider and reconsider the code that we're already familiar with in the context of all the new knowledge that we've gained. How might what we already know change given the different project that we're working on? For example, our server needs to run on some ports. But remember, our Create React app front end over here runs on port 3000 by default. So it helps us if we run our backend server on a different port. Let's say port 8000. This way, it doesn't conflict with the port that's serving our front end on port 3000. And we'll also make our port configurable so that it defaults to 8000, but the server administrator can specify which port it should run on as an environmental variable, which we can access by calling the built-in process module. And just like we called our args to get the command line arguments, we'll be calling process.env to get the environment, specifically the port variable. And then we'll use this OR syntax, which effectively checks if there's a port specified in the environment, and if not, if that's undefined or falsy, it goes to the default 8000. So now if we decided later on that sometimes we want to run on port 5000 in our package JSON, we could specify as an environmental variable the port using this syntax, port equals 5000, and then node source/server.js. So now in our server.js, if we, let's say, just log the port and save our package.json, what's going to be logged when we run npm start? npm start, check it out. Our port was set to the environmental variable. And now if we remove that and run our program again, we have the default 8000. Now, in our server.js, we could import Express like we did before, set up Express, and call app.listen on that Express object. But let's demonstrate another very common way of creating an Express server, which is a little bit more flexible. So I'm going to comment this out for a second and remove our log. And we're going to instead create our HTTP server using the Node built-in HTTP module. and we'll assign our server to the result of http.createServer, which takes in as an argument that requestListener function, which responds to all incoming requests to our server. So we'll see something goes into that function. But first, let's start our server up with server.listen. And we're going to listen on this port over here. So it needs to be defined above. And we're going to log when our server is ready. So in our callback function, we'll log which port it's listening on. Listening on port. So far, so good. But what handles our requests? What do we pass in to create server? Well, the truth is, we can take our Express code here, specifically these first two lines, and if I copy them over to the top of my file here, I can now pass in Express, this app object specifically, into create server. And any middleware and route handlers that I attach to this app object will respond to requests coming in to our server. Express is really just a fancy listener function for our built-in Node HTTP server. And the listen function that we get from Express that we can call on app is exactly the same as the listen function on our server object. We can use either of them to start our Express server. The added benefit of this is that now we can organize our code a little bit more by separating the server functionality that we have here from our Express code, which we're going to put into a new file called app.js. And this is going to have all of our Express code. So let's move that out of server.js into app.js and set the module.exports to be this app object from Express, which we can now import in server.js. So it's going to be const, and the app is now coming in from this relative import, require /app, and that's the app that we pass in to our HTTP server. We'll see later in the course, when we talk about things like WebSockets, that starting our server in this way, using the built-in HTTP server, allows us to not only respond to HTTP requests, but also to other types of connections. For example, to use WebSockets for real-time communication as opposed to sending requests and waiting for the response. We're going to have a lot of fun with that. But for now, we can truly see that Express is just middleware that we add on top of the built-in Node HTTP server, which we can use to organize our request handler by making routes and using middleware. For example, we know that our Express server is going to take in some JSON data, so we can use, using our middleware function, the built-in express.json middleware, which will parse any incoming JSON from the body of incoming requests. And now we've separated all of our Express middleware from our server functions to organize our code just a little bit better. This is a structure that we can use for any scale of Node application going forward. Let's implement some more functionality in the next video. I'll see you soon.